welcome to Crimsafe Talking Tech. My name is Alex Somerset. I'm Chief Designer at Nissan Motorsport, and I also am race engineer to James Moffat on the Norton 360 car. Today we're going to talk about what happens when a new manufacturer joins V8 Supercars and how they would place their body on the car of the future chassis. Here is a simple CAD model of the car with essential parts of the bodywork on. The highlighted part in red is the standard car of the future chassis. The individual components are the race car body parts that we need to make the front bar, front guards, rear quarters and side skirts. Once the front bar has been designed and tested, we need to make that into a easily manufactured component, which was usually a combination of carbon and Kevlar and some glass fibre. We have to produce what we call a pattern. So effectively we create a full-size solid model of the front bar as it should be, with all the openings closed off. And this is machined in a material called Uriel. The brand of Uriel we use is ProLab 65, sourced from Melbourne, and the whole tool, being solid, weighs close to in excess of a ton, so it needs a forklift to manipulate it once it's been machined from a solid. It takes over a week and a half to machine on a 5-axis machine. After our final discussions with V8s over the placement of the body on the car of the future chassis, it was mandated that the rear wheel stay in the center line of the standard rear wheel arch. Made it a little bit simpler on the rear for the bodywork. The only thing we ended up doing to the rear bodywork is actually widening it by about 25 millimeters per side to meet the project blueprint and allow for wheel clearance. As we were constrained from the rear, we now had to move this front wheel and axle centerline 46 mm forward. And with the tyre growth and the lowering of the body, we ended up having to make the wheel arch opening much larger than the standard. And that really proceeded in making this point of the front 100 mm further forward than on the road car. The biggest problem that encountered was that the fixings for all the lights were now exposed by the wheel arch, so we had to take away a lot of the fixings from the rear of the headlight, which makes it a bit of a headache trying to keep the headlight in situ when we're racing. The easiest part of the front arch was that we had to do very little flaring at all, because the OEM car is only 3 mm under the maximum body width at the front, so very little shape change had to occur at the front of the arch. All these changes that we made had to be run by Nissan, so we would come up with a drawing, we would present it to Nissan would be happy with it, then we would present it to V8s. And if V8s were not happy, we had to go through the whole process over and over again, which thankfully was only 2 times on this occasion. The biggest constraint on the height of the overall bodywork on the car was the fact that the main roll cage hoop needed to be as close to the roof panels as possible, and we had to strike a compromise between being too high or coming down too low and having to do a lot of fabrication work to make it happen, like widening the car at the top. In the end, we've reached a compromise whereby we were slightly higher than the Holden and roof line, but without having to do major panel work. In current FGs and VEs have to have a roof panel cut up in 4 parts to make one single roof panel, which we were able to avoid and use the original panel, and then thus respect the bodywork shape of the Nissan Altima to the manufacturer's wishes. Although this Nissan Altima looks exactly like the road car, bar some go faster, wide body flare kits, there's nothing stock about this car. We run the standard aluminium boot. The rear quarters are made in glass and Kevlar. The rear door skins are in Kevlar. The only steel work that's on the car is this one panel here, the front A pillar, the sill section, the steel roof and the aluminium bonnet. They're the only things that we take directly from the road car in terms of bodywork.
Buying security screens? Most Crimsafe lookalikes can pop out in just a few seconds, but the real Crimsafe doesn't, thanks to its patented screw clamp. Cheap lookalikes can pop out because they're only held in with a piece of plastic. But Crimsafe screw clamp locks the mesh and spreads the impact. Crimsafe resists attack and corrosion and now has the ultimate warranty, 15 years. Ask for a demonstration today, because if it's not Crimsafe, it's not Crimsafe.